Hello there, I'm Sanket. I'm studying Master of Science in Wireless Embedded Systems at Newcastle University. Today I'm here to represent a reservation smart parking system based on IoT. Client which can access a website through his desktop and a mobile collector which can also access a website from his mobile device. When he requests a parking slot availability, the data gets transmitted from access point to the database, and it's checked whether which parking slot is available for parking. It is done with the help of sensors. The sensors here we used are ultrasonic sound sensors, which can detect an object within 4 meters. As soon as the object is detected, the data is passed through a gateway, and then the static data collector forwards it to the database. Each time the database updated every second. So as soon as the availability of parking space is shown, it also gets transmitted back to the gateway, and gateway transmits it back to the client who requested about the availability of space. As we can see, we have used a Django web server application to display our website. When user requests a website from the local host, a URL and the views.py is been carried forward, and it communicates to the model and template that we designed in HTML and CSS3. This is a detailed Django flowchart. When the user accesses a browser through a local host, it sends a request to the request middleware. After sending a request middleware, it then reads the data from the URL config. The URL config is passed to the view middleware, where all the views are saved in the views.py. This views.py is then accessed by the model.py and the manager and the database. When database is updated every second, the data gets transmitted from model to the templates, where you can see a website and the availability space for the parking slots. After doing the models, after accessing the templates, actual website is being displayed to the user through a browser which he can access on his desktop or his mobile device. Now let's see how does this works. When driver accesses the website, the user interface can see the available parking slot, the reserved parked slot, and the occupied slot on the website. When driver books the available parking space, the slot is allotted to the user. As you can see, the slot is reserved. The first slot is reserved. The user can park his car within half an hour. When driver parks the car within half an hour of booking, time starts. As soon as time starts, the driver can leave his parking space within the allotted time. If driver runs out of time, he can if its time exceeds the allotted time, for customer gets fined for 15 minutes. When the driver parks the car but didn't arrive at the parking slot, he will be charged after half an hour, and that reserved slot will become available again. This is an actual system which I built. Here is a Raspberry Pi. These are ultrasonic sensors which can be represented the availability of slot with the help of LEDs and a website. Now we will see the prototype, how it works. Moving towards our prototype, let's see how it works. Here we have considered 5 parking slots: slot 1, slot 2, slot 3, slot 4, and slot 5. We have used ultrasonic sensors to measure the distance between the actual car parked at the slot. Also, we have used the LEDs, which represents the parking slot availability. We have interfaced these ultrasonic sensors and LEDs with the Raspberry Pi with the help of jumper wires. This is a VNC server from which the Raspberry Pi can be accessed. Now we will log in into Raspberry Pi for further instructions. Now By accessing the terminals, we need to change the directory to desktop because our main code is saved to the desktop. By changing the directory, now we can run our main file called sensor.py. By opening the root directory, we can access the website. By changing the directories to downloads and to the parking which we created for our website, we then run a main server called manage.py. After configuring the website, now we can access the website from the local host. Typing in our local host address, which is 127.0.0.1.8000/index, we can actually see how does the website looks. As discussed earlier, we have used slot 1, slot 2, slot 3, slot 4 and slot 5 to represent our parking sensors. Now, by running the code, after configuring our website, you can see it gets updated every second. Now, after running our code, we can see that all of the sensors are available. That's why it represents the green LEDs on each sensors. As soon as car parks in slot 1, the sensor gets red. That means the sensor gets occupied. As soon as sensor gets occupied, the slot gets occupied. It's shown with the when a user accesses a website, you can see a slot 1 is red. That means it is occupied. When the next car moves into the slot 3, it gets red. That means the slot gets occupied. The system, the website also updates every second the real-time availability of the parking slot. So here slot 3 is occupied. Now when user reserves the parking slot, it says that parking slot has been reserved, and you can see that the yellow LED for slot 2 is on, as well as the website shows that this park is reserved. If user wishes to unreserve the slot, he can unreserve the slot and the slot becomes green again. As you can see, the LED for slot 2 is green again. That means other users can park their cars. 2 and slot 4 are reserved. As soon as car parks in the reserved slot, the slot becomes. As soon as the reserved slot gets parked, it turns red. Also, the system website gets updated to the slot, which you can see it is occupied. After car moving out of the parking space, the parking slot becomes available again. And the reserved slot, if is not occupied within half an hour, the slot who reserved it will be charged as per the 15 minutes. And after half an hour, it will become available again automatically. It will also update the system, which will show that the slot 4 is available again for next user to park his car. As soon as the car 1 leaves the slot becomes available again, and the system gets updated as all slots are available. So, to conclude, This is the reservation smart parking system which I designed with the help of Dr. Graham Chester, Dr. Alex Bistow, and Dr. Fiache. I really appreciate their help towards this project. I would also like to thank my friend Konstantinos, who helped me to record this video. And I'm really thankful to my Indian friend Ketan, who helped me in this project as well. So this is a reservation smart parking system proposed by me. Thank you.